Welcome to yet another class of system modeling and simulation. Today we're going to deal with unit 1, that is single channel queuing system. Let's look at the problems and what single channel queuing system actually means. So let's get on with the video. Okay, so let's look at what a single channel queuing system means. So a single channel queuing system has three components. First you have the calling population, the waiting line and the server. So the calling population has the customers or the orders that are yet to be processed. The waiting line is the line in which the orders are waiting in order to get served by the server. The server processes all the requests given by the customers or the orders, and after it is done processing, it is again sent back to the calling population to wait. So a few things to remember is that the name single channel is due to this single channel that appears here. It is a single flow of orders, so there is no end channels that are there. It's a single channel through which orders are processed and sent to the server. And the calling population is infinite. Okay, so there can be any number of orders or customers that want to be served by the server, so there is no limit on that. And the arrival for services, that means the arrivals of these services are of random, can occur at any time, and therefore they are in a random fashion. The service times of these orders are also random. That means the service time of this is not dependent on this. So they are random and they occur in a random fashion. And the last thing, the system capacity, that is this particular waiting line, has no limit again. Any number of items or any number of orders or customers can wait in the waiting line without having a limit. So with these few points, let's move on to the example problems that we need to solve. Okay, so the first problem lists this. A small grocery store has only one checkout counter. So this gives an indication that it is a single server. Customers arrive at this checkout counter at random from 1 to 8 minutes apart. So this is their arrival time, 1 to 8 minutes. Each possible value of inter-arrival time has the same probability of occurrence. The service times may vary from 1 to 6 minutes with the probability shown in this table, table 5. The problem is to analyze the system by simulating the arrival and services of 6 customers. So we know that it is a single server queue problem. They've given us the arrival time, that is 1 to 8 minutes, and then they've given us the service time table. And what we have to calculate is these 7 things. So it includes waiting time for a customer, the idle time, service time. So let's look into how do we actually proceed. So for that, we remember in the previous section that we said that the arrival time and the service time of each order is random. So you do need random numbers for all these 6 customers. So as you can see, since you've said simulate the simulation for 6 customers, hence we have 6 arrival times and 6 service times. They are in a random fashion. So how do we convert this randomness into something that we understand, right? So that is what we do in the next step. So this is one table that will be useful. So the next thing that they tell us is assume that the first customer arrives at time 0. So our timeline starts from 0. So let's look at how do we convert this particular thing and use this data to calculate these few things. Okay, so we have the service time table given here. The only thing missing is the arrival time table. So let's look at how to make the arrival time table. So like I said, the first step in doing a problem like this is calculating the arrival and service time table, and then you get the random number assignment. Okay, so this particular table is called, it's the distribution of arrival time, because we need the arrival time. Okay, so the first thing is time between arrivals. The thing that they have mentioned is the thing that they have mentioned is that it is 1 to 8 minutes apart. So we know that the arrival time lasts from 1 to 8 minutes. So the thing that we have to write is 1, 2, 3, 4, 5, 6, 7 and 8. So the probability of this occurring, that means time between arrivals is 1, 2 or 3, is same because like I said in the problem, it also states each possible value of interval arrival time has the same probability of occurrence, right? So that means every probability is the same as 1 by 8 because there are 8 arrival times, that is equal to 0.125. So probability for each thing remains the same. So I'm just going to write 0.125. Similarly for this. It's not necessary that it always is the same. Since they've not given and they have mentioned that it is same, we have taken it as 1 by 8. Okay, so the next thing that comes is cumulative probability. Cumulative probability is the addition of the ones that were above it. So since the first case, there's nothing above it, so this will remain 0.125 itself. The second row for this particular column will be the addition of these two. So 0.125 plus 0.125 will give me 0.250. Similarly, for the third, it will be the addition of these two. That will give me 0.375. And going on, so I get 0.500, 0.625, 0.750, 0.875, and lastly 1.00. A measure to check whether all your calculations have gone correct is that at the end you are supposed to get 1, because at the end the cumulative probability lies between 0 and 1, so the final value should be 1. So this is like a measure to check if the last instance in this column gives you 1, that means your summations have been right. So now with calculating the cumulative probability, we can assign the random number associated with each arrival time. So as we said, so random numbers last from 0. So 0 to 125. Similarly, 125 cannot come here. So it is 126 to 250. Right? And similarly, this will be 251 to 375. 376 to 500. 501 to 625, 626 to 750, 751 to 875, and finally 876 to 1. So anything above that comes here. Okay. So with this we get the random digit assignment. So this is helpful. This particular column will tell me where the random digits lie. So since we have calculated the arrival time table, now it's time for the service table. So for service table, since they've given this particular table, the first two columns of our table is filled. So let's see. So we are done with this particular thing, distribution of arrival time. Now when we come to distribution of service time, so similarly the table is given, so service time 1 to 6 with these probabilities. So let me just write that down. So I have 1, 2, 3, 4, 5 and 6 with the probabilities going like 0.1, 2, 0.1 and finally 0.05. Similarly, I calculate the cumulative probability. This stays 0.1. This is the addition of both of them, so 0.3. Similarly 0.6, then 0.85, 0.95. Finally we get 1. Again it gives me 1, so it tells me the additions have been correct. So now how do I assign the random number? So it starts 1 to 10. Now you might get confused. It stopped at 1, so how do I make it 10? So you see how many digits are there after the decimal point. We have 2, so that indicates you append a 0. So 1 to 10 lies here, 11 to 30 lies here, 31 to 60, 61 to 85, 86 to 95, and finally 96 to whatever is above. Okay, so this again is a random digit assignment. Using this, we can calculate where the particular random numbers that have been given to us, where do they lie in this service time. Okay, so our next step would be, that is step 2, would be determining time between arrival. So the second step would be determining time between our arrival. So we have been given with some random numbers, right? So let's look at that. Okay, so our first 2 steps are done. We've calculated the arrival in the service time table. Now the second thing is getting the random digits that have been given to us in these tables, converting those, basically these random numbers, converting these into actual meaning of the data. So for that, so like I said, so let's determine the time between arrival. So we have 1 to 6 customers. So now the inter-arrival time for the first customer is nil because it is the first customer. So there is no possibility of having an inter-arrival time. So that's why we give it on a nil sign, meaning that the first customer does not have any inter-arrival time. From the second customer, do we start with our values? So 7913, 727, 15, so on, get filled up here. So let's see how do we find out time between arrival using this data. So since the first customer does not have anything, we just give it none. So now we know the next random digit is 913, right? So let's see where 913 lies in our arrival timetable, that is over here, right? So 913 lies in this 876 to anything above that. So that will give me as 8, right? Time between arrival in minutes. So using this random data, we find out where it actually lies. So let's look at the next data, 727. 727 lies here, 626 to 750. That is 6. So we write 6. Similarly, we find where 15 lies. 15 lies in 1. Then 948 lies in 8. And 309 lies in 3. So this is how we get the time between arrival. First being nil, then 86183. Similarly, this is for arrival time. We also need to calculate one for the service time, right? So we do that using the same method, but since here we don't keep the first customer as nil because the first customer will have some service time, right? So this is the random digit again got from this table, right? So this is the table where we fill out our table over here. So 1 to 6 customers, the random digits associated with it, and then using this random digits we find out where it lies. So 84 lies in here, so that will be 4. 10 lies in 1, similarly 4, 3, 2 and 4. So this are the first 2 steps to calculate the next table that will help us calculate the average waiting time, the service time, as the question had suggested. So keeping these 2 steps in mind, these steps are, by doing these steps you are halfway across the problem. Okay, now we come to the part where we look at this overwhelming table. So this table looks big, but it is quite simple. There is nothing to worry. 3 columns are what we already did. So what this table actually means is we are actually simulating the 6 customers. So basically we are providing a timeline. What we are doing is we are telling the customers the inter-arrival time, arrival time, the service time that it has, the time the service actually begins, waiting time, the time the service ends, then the total time spent in the system. That means how much time the service is there in the system, and then finally the idle time of the server. So if you just remember these few things, look at it as a chain of events that happen. So you can remember these things, and since it's 6 customers, so we have 6 rows that tell us each customer's details. So this table is got from the first table that we had calculated, the inter-arrival time. So where we had the random digits and we saw in which range they lie in, and then finally got this. So we have this from that table, and so is this one. So finally, how do we start with the third column, that is the arrival time. So arrival time, since we know it's on a timeline, right? So the first arrival time, we also had in the question that, assume that the first customer arrives at time 0. So hence the service time or the arrival time for that particular customer becomes 0. Now this customer, the next customer will be the addition of this. So 0 plus 8, similarly 8 plus 6, 14, 15, 15 plus 8, 23, and finally 26. So arrival time of each of these processes. So this table is got from the previous table. So when does this service actually begin? So this arrives at time 0 since there was nothing before it. So this can easily start at time 0. Now this particular thing, how much does it have to wait in the queue before it actually starts? Since it's the first customer, there's no waiting time, hence we have 0. Now when does the time service ends? Since it started at 0, the service time is 4. When you add these, you get 4. So it ends at time 4. Now the total time spent in the system is the addition of these two, right? In the system is the service time plus the time it waited in the queue. So this will be 4. Idle time of the server is 0 because since the time it started, it's been using all the cycles. So coming to the next customer, so the time the service begins. So this has ended at 4 and it has arrived at 8. So it will start only at 8. Waiting time, again it didn't have to wait because as soon as it arrived, the server was free, so it could handle it. The time the service ends is 8 plus 9. 8 plus 1, sorry, 8 when it begins, and the total service time, so this will give me 9. Time spent in the system is again the time it took since its arrival, so it is 1 again because 1 service time and it didn't have to wait in the queue, that's why 1. Idle time of the server would be 4 because it ended at 4. Right, the first customer service ended at 4 and then the next thing started at 8. So there was a difference of 4. So that's why we write as 4. The next customer would be the same thing. This one ended at 9. This one came at 14, so there's no problem. We can just write 14. It began at 14. Waiting time, again it didn't have to wait anything, so this is 0. Then the time the service ends is 14 plus 4, 18. Time spent in the system is service time plus the waiting time, that is 4. And idle time of the server is again, since it stopped at 9, right? And it began at 14, it's right here. So the difference is 5 and that's why the idle time is 5. Now for the fourth customer, now this particular thing ended at 18, correct? Arrival time is 15. So that means it came before it actually ended. So it has to wait until this thing gets over. So the time service begins is at 18. So it can't be 15 because at the 15th time this process is still going on. The third customer is being served. Hence the 18th at time 18 the fourth customer gets served. So 18 is there. Waiting time. Now waiting time would be it had to wait for 3 minutes before it could start. Why? Because it ended at 18 but it arrived at 15, right? So this minus this will give me 3. Time the service ends is 18 plus 3, that is 21, right? Time spent in the system, over here we'll have to add the waiting time and the service time, so that is 6. Now idle time of the server, since it didn't have to wait anything, because as soon as it was ended, it started a new process. So that will be 0. Similarly for 5th customer, now it ended at 21, it arrived at 23. So there's no problem. I can just write service time begins at 23. Waiting time, again it didn't have to wait, because as soon as it arrived, the server was free and it can be accessed. So 0. Time service ends is this plus this, so 25. Time spent in the system is service time plus waiting time, so that's 2. And idle time of the server was the previous thing ended at 21 and this started at 23, so the subtraction of these two will give me 2. Now for the last customer, we have time service begins. So this previous thing ended at 25, it arrived at 26, so again no problem, begins at 26. Waiting time, no, because as soon as it arrived, the server was free. Time service ends is 26 plus 4, that gives me 30. Time spent in the system is service time plus waiting time plus, that is 4. Finally, the idle time of the server is this minus this, since it is 1, so we have 1. So we have got all the data. Now what we have to do is we have to add the service time, and one more thing that I want to make sure is all the service time, it's in minutes, right? Any time that you see over here, all this minutes. So all the values or all the units are in terms of minutes, right? So when we add this up, we get 18. Okay, when we add this up, the total waiting time, it is 3, and this one is 21, and this particular thing will be 9, 10, 11, 12. Right? So we have the total. Now comes the part of calculation, which we will look in the next section. So after finding the big table, what we have to calculate that's given in the sum is these 7 things. So let's look at how we calculate each thing. So first thing is finding the average waiting time for a customer. So we know the average waiting time is the total time the customer waits in the queue divided by the total number of customers. So we know the total time the customer waits in queue is 3 divided by total number of customers 6. So that will give me 3 by 6, that is 0.5 minutes. So the second thing that we have to calculate is probability that a customer has to wait in queue, right? So that would be probability a customer has to wait in the queue. That is given by total number of customers who actually wait in the queue divided by, again, the number of customers that are there. So the total number of customers who wait is just 1 by looking at this table. So there's only one customer waiting, so that's 1 divided by, again, 6, the total number of customers. This gives me 0.166 or 16.6%. The third thing that we have to calculate is probability of idle time of the server. So idle time, the time the server was idle, so that is given by the total idle time of server, so that is 12. So the total idle time of server divided by, so total idle time of the server divided by the total run time of the entire simulation. So we know idle time is 12 divided by 30 because the time the service ends, the last customer is served at time 30. So 12 by 30 gives me 0.4 or 40%. The fourth thing that we have to calculate is the average service time That is given by the total service time divided by the total number of customers. So total service time is 18 divided by number of customers 6. So that gives me 3 minutes. The next thing that we have to calculate is the average time between arrivals. That is given by sum of all time between the arrivals. So the sum of all the inter-arrival times that we have divided by number of arrivals minus 1. So why is this number of arrivals minus 1? It is because the first customer has no inter-arrival time. So we don't have to consider the first customer, right? So because of that, we have number of arrivals minus 1 and not 6. So sum of time between arrivals is 26, as we see from this table. The last arrival time is 26. It is nothing but if you add all the inter-arrival times, that is 8, 6, 1, 8, 3. So 26 divided by number of arrivals minus 1. So 6 minus 1, 5. So 26 by 5 gives me 3.5 minutes. So the sixth thing that they ask us is average waiting time of those who wait. So this is given by total time the customer waits in queue divided by the total number of customers that actually wait. So the total time the customer waited was 3 divided by only one customer waited. So 3 by 1 is 3. Okay, so I made a mistake. 26 by 5 is not 3.5. So that's a mistake. So please correct that. 26 by 5 gives me 5.2 minutes. So I'm going to write that. So it's 5.2 minutes. Okay, the seventh thing that they ask us to calculate is the average time the customer spends in the system. So that is equal to the total time customer spends in the system divided by the total number of customers. So total time it spends in the system is 21, that we know from this table. So total time it spends in the system is 21 divided by the total number of customers 6. So 21 by 6 will give me 3.5 minutes. Right? So we've calculated the tables. We know what is there. So using these steps and these formulae, we solve the sum.